Hi everyone. Today we are diving into the buffer overflow attack using the Seeds Lab environment. First, we need to download the zip file of the lab setup and we need to extract it so that we can observe two files in the setup folder. Terminal, we can use observe the stack C program with vulnerability of string copy function. So string copy vulnerability because it does not check the boundaries allowing us to override write an address on the stack, which means instruction pointer to pointer or malicious shell code that we can rewrite the root of the program so that the goal level one is that to master the fundamentals of hacking the instruction pointer. In this we have 32-byte system here with a file. So in that we need to replace the shell code with a 32-byte file. We need to copy this and paste in the our exploit file py file, and this run we need to disable ASLR and stack out with the command. So this command is used to disable the address base layout randomization that is by setting it to 0 memory static, so address is found in the so by using command, we are changing the secure shell and the dash into the execute the exploit py, and to find the buffer size and the pointer values we can go to gdp terminal by using the command. So here we can find the vulnerability of the stack, and to find the pointer values we use the commands. These are the pointer values. For the offset value, we need to difference between here. We got the offset value 108, and we will use the offset value in the exploit.py, increasing into 4 bytes, and the return address will be changed the return addresses. We can increase it, overcome the stack value and execute our shell code. Now we are going to run the exploit.py file. We need to run our stack. Here we can also need to change our start point because we have to overcome the return address. The start point should not be at the low, and we will run it again. So we have overcome, and here we can verify it by so EUID is 0 and we have the root access. So this is level 1. Similarly for level 2, the goal the goal is to learn how to succeed when you don't know the exact buffer size. So we'll almost apply the logic, but we have to know idea buffer size. So here make small changes in the exploit.py file. That is, we can have no idea buffer, so we have comment out the start point. So now we'll run this file. So we are successfully overcome the level 2 when we can verify it by same method, and we have the root access. So for level 3, the primary goal is overcome the null byte constant of 64 byte. So for level of 1 and 2, we can mostly use a 32 byte. We will use the 64 byte. So using the same method, we can replace the 32 byte shell core with the 64 byte shell core. In the start point would be the 570, which is the extract bytes of the bad file minus length, and shell code we will make the same changes in the offset, and it is a 64 byte. Make the L equal to 8 value changes level in the 3 is successful. We can verify it, and we have the root access for level 4. The level 4 goal is to execute an attack when the buffer is too small to hold a payload. That is, the buffer is tiny. For example, 10 bytes. We cannot uh, file the cell code inside the 10 byte hole. So for that, we have so we made small changes in the return addresses and the offset based on the goal of our level 4. So we, as you were seeing, we can have the root access. We overcome the we achieved all the goals of 4 levels. Thank you.